Welcome back. Today we're going to talk about equations with no solutions and equations with infinitely many solutions. Okay, so in the past we've been seeing equations that look just like this, where if I isolate the variable here, I can just quickly get what this is. Right here, 3x is equal to 18, divided by 3, x is equal to 6. Okay, so there's actually one solution to this equation, that's the number 6 here, and it's the only number that I can substitute in for x in order to have this equation, the right-hand expression, equal to 22. Okay, so this is an example of an equation with one solution that has everything to do with the idea that x is raised to the first power. Now we are going to see equations that are like this, that have two solutions, and actually you can sort of figure this out anyways because we've had square roots before. So you can see that if you subtract 5 here from both sides, you'd have x squared is equal to 144. Okay, and that means that when I take the square root of both sides, x is going to be 12 and negative 12. So this has actually two solutions here. And again, that has everything to do with the fact that the x is raised to the second power. Now, let's talk about equations with no solutions. So with equations with no solutions, sometimes you can see them right off these are both equations with no solutions. Okay, sometimes you can see them right away that there's no solutions. Like here, the left-hand side is a quantity x multiplied by 2 plus 4 is the same as the quantity 2x. Now there's nothing that I can put in here for x that when I add 4 to it, it's the same as just multiplying it by 2, right? Or when I take x, I multiply it by 2 and add 4 to it, it's the same as multiplying, because essentially look at the symmetry here. This one here, or the anti-symmetry here, this one here says plus 4 and this one here is a plus 0. There's nothing I can put in here for x. If you tried to solve it, what you would get is you'd subtract 4 from both sides, and you'd get 2x is equal to 2x minus 4. That wasn't that helpful. Let me see if I can subtract 2x from both sides. We'd get this on the left-hand side, I have 0, and then this also cancels out, right? They both cancel out, and I get 0 is equal to negative 4. This is a false statement. I cannot have 0 equal to negative 4. When you arrive at a false statement, you know that you have come upon an equation with no solution. And it's very possible. It just means that the equation, there's nothing that you can insert into the equation to have x can't be equal to anything such that the left-hand side is equal to the right-hand side. This again, if I tried to start solving this, I could say, oh, this is negative 8x plus negative 4. And again, this is the right-hand side is negative 8x minus 2. And there's no way, like here, if I added 8x to both sides, I would come up with the statement that, because these would cancel and these would cancel, I'd come up with a statement that negative 4 is equal to negative 2, and that's, again, that's false. So one integer can't equal the other integer. So in this case, you're going to come up, when you have an equation with no solutions and you try to solve it, you're going to have a situation where you have like a is equal to b, where a and b are integers. And you know this is a false statement. So if this is a false statement, it can lead you back to the idea that there's no solutions to this equation. Because basically you assume that there were solutions and you arrived at a false statement. So you have to backtrack and look at your assumption. Your assumption has to be false because you arrived at a false statement. Okay. Now there are also equations that have infinitely many solutions. So for instance, if we look at the top one, it's just something is equal to itself. What can I put in here for x, right? A solution is just what I can substitute in for x so that the left-hand side is equal to the right-hand side. There's a whole bunch of stuff. There's actually infinite amount of things that I can put in here for x because the two expressions are equal to each other. Look what happens when I try to solve it. So I subtract 4 from each side, okay. We have 3x is equal to 3x. And I subtract 3x from both sides, and I end up getting 0 is equal to 0. So when equations have infinitely many solutions and you try to solve them, you end up just saying 0 is equal to 0, or some other truth statement like, you know, you could have 1 is equal to 1. So if you have an equation with infinitely many solutions, instead of getting a equals b, that's what you got with no solutions, you would get a is equal to a. So an integer is equal to itself. When you get this, you know that actually the two expressions were equivalent on the left hand and the right hand side of the equation, and that there are infinitely many solutions to this equation. So let's try to solve this right-hand side here. If I distribute this through, this would be, oh, that's 8, is equal to negative 5 minus 9x. Here I can add these two together. 3 minus 8 is negative 5, so this would be like negative 9x minus 5, and negative 5 minus 9x. Remember, we can just switch this around into negative 9 minus 5x, or 5, and that's equal to negative 9x minus 5. This expression is equal to this expression, so if we use this, if we started to subtract everything, eventually we'd arrive at the statement 0 equals 0. So that means that our equation had infinitely many solutions, which means that I could put in any number. I could put in 1, 2, 3, 4, 1.5, 2.5. I could put in pi here. I can put in any real number for x, and it would be a solution to this equation. Okay, to build equations with no solutions, you want to start with you want to work backwards and start with a nonsense. So let's say 1 is equal to 2, which you know is false. Okay, and then we can do the same thing to both sides, like 1x is equal to 2x. Okay, so I've multiplied them. Actually, there's an x here that 0 would work in this situation. So we can add things like x's to both sides. So 1 plus x is equal to 2 plus x. You could have said 1 plus 2x is equal to 2 plus 2x, and that's still an equation with no solutions, because the right-hand expression, there's nothing you could put in to have 2x plus 2 be the same as 2x plus 1. Okay, so start with something that isn't true and work backwards. But make sure that the first step I made was incorrect, because if I multiply each side, if I start here and I multiply each side by x, there is actually a solution to this equation, and that would be 0, right? If I put 0 in here for x, I'd have 0 is equal to 0. That's the only solution to this equation, so don't do that. All right, how to build an equation with infinitely many solutions? Again, start with something that's a true statement. So we go 2 is equal to 2, sure. Let's do the same thing from both sides. Let's go 2x is equal to 2x. You could do something tricky, like you go 2x plus 2 is equal to 2 times x plus 1. So I've multiplied both sides by, or I've added 2 to both sides, but see that the left-hand side is equivalent to the right-hand side. Basically what you're doing is just building an equation where you have an equivalent expressions on the left and the right-hand side, okay? And then you have an equation with infinitely many solutions. Right, let's see if we can determine how many solutions each equation has. So if you want, you can pause the video and see if you're correct when you come back. So here, if I start to subtract, like let me subtract a here, I would say 3 is equal to a plus 3. And here I can already see if I subtract 3 from both sides, I'd have a is equal to 0. So be careful, because actually this actually had one solution, which is 0. So I could put 0 in here, and then the left-hand side would be equal to 3. And if I put 0 in here, it'd be 2 times 0 plus 3, but that's just 0 plus 3, which is 3. So there's actually one solution to this equation, and that's because I could put 0 in here, and that would knock out this term right here. So the constants are the same, but the coefficients on the a are not the same, but that's fine, because I could always knock out that coefficient by substituting the value of 0 in, or knock out the term with the coefficient. Okay. Here, if I multiply through, I have 5b plus 10 is equal to 5b plus 9. So in this situation, since these are the same, but the constants are not the same, there's no solution to this equation, because if I subtracted 5b from both sides, I'd arrive at the statement that 9 is equal to 10, and you know that's not true. So there's no solutions here. Okay. Sometimes when there's no solutions, we use a little symbol called the null set, which is like this 0 with a slash through it. Okay. We can also use these brackets that are like curly brackets, but they're empty inside. So no solution comes in these. Sometimes it's written as like curly brackets that are empty, or this symbol that's like a 0 with a slash through it. That's called the null set. It's a German derivative set. Okay. Okay, let's multiply this through here. So we'd have 6h plus 12 minus 3 and we have 6h plus 9 on the side, so let's carry that down. And that's, if I combine those, I have 6h plus 9. So here the left-hand side is equal to the right-hand side, so there's infinite amount of solutions, okay? Right, and that is the end of the lesson for today.